Finally tonight, a dance partner for planet Earth. It's called a Trojan asteroid, one that shares a planet's orbit circling around the sun. Many such asteroids have been found near other planets. Now, as reported in the journal Nature, the first has been discovered near the Earth. We get an explanation from Mike Brown, a planetary astronomer at the California Institute of Technology. So tell us a bit more about a Trojan asteroid. In this case, it's held in the gravitational pull between the Earth and the sun?
That's right. It's not between the Earth and the Sun. It's actually in the same orbit as the Earth. So it goes around the Sun in 1 year, just like the Earth goes around the Sun in 1 year. And on average, it's about the same distance from the Sun as the Earth is. So we're really just following it along in its orbit around the Sun.
Now, if it's relatively close, and how close is it exactly? Why is it taken so long to see?
It's close, and it's so close that on average we overtake its position about every 2 months. So in 2 months from now, we're going to be where it is right now. The reason it takes so long to see, the reason it's been so long to find one of these things is because most of the time when we're looking for asteroids or anything else in the solar system, we look out beyond the Earth. We look into the night sky to find these things that are actually in the same orbit of the Earth. You really have to look in the very early morning or the very, very early evening as the sky is really quite bright. So no one has found these things up until now.
And do we know where it came from, how it got there?
That's actually the really interesting question. It's only been watched for a little bit of time right now, and it's on this very intricate dance in front of the Earth. And so figuring out how long it's been there or exactly where it's going to go is a difficult thing. What we know right now is it has been in its approximate position for at least 10,000 years. 10,000 years, though, is a really, really short amount of time for the solar system. So we don't know if it's been there forever, 4.5 billion years since the solar system formed, or if it's really just essentially fell into place yesterday.
You know, you referred to it as a dance. We had a graphic up, and maybe we'll run it again, this animation. It's not really running alongside the Earth. It's constantly moving as well.
Yeah, it's on average it stays 60 degrees in front of the Earth as it goes, but it doesn't really stay in that spot. It goes ahead and then comes back behind and then keeps circling around, and so it's in this position where it's a stable orbit where it can stay in that place for a long time, but because of the Earth and because of the Sun, it keeps on moving it around.
Now, what is the importance of asteroids, of finding and studying them? What do they tell us? There's even been talk about, of course, a NASA mission where we could get to one, right?
Right. So there are two ways to think of asteroids, at least the way I think of them, is that they're sort of technologically interesting and sort of sociologically interesting in that they might be the next place that we go to in manned space flight. They're sort of a natural stepping stone to go to the next even further destinations like Mars, perhaps. They're also something that we care a lot about because they are continuously pummeling into the Earth's atmosphere, and there is always that chance that one of them might have our name on it and be coming in our way. So the more we know about them, the better we are prepared to deal with that possibility. For me, though, I think they're interesting much more because of their scientific interest. They really are these windows into the very earliest solar system. They're materials that are left over from when the Sun and the Earth and the planets formed, and they've been sitting around in space for that past 4.5 billion years. And if we can find them and study them and figure out where they are and where they've come from, we've learned an awful lot about our very own origins.
And just briefly, just since you raised it, we better reassure people because of that fear of asteroids coming to Earth. This one is sort of stuck in place, right? So that's not likely?
Yeah, this one is actually a really good one to have found because even though it has the same orbit as us, it can never come any closer to us than a certain distance because it's stuck by the Earth. Never, okay, maybe in 20,000 years, we don't know what's going to happen then, but for the foreseeable future, it's going to be staying there. We're going to be watching it. It's going to be a really fun dance to watch.
Okay, reassuring in most of our time frames. Mike Brown, thank you very much.
It's my pleasure.